Okay, so in the previous section, we looked at how event-based driven communication is a good way of sharing data across our microservices. In this section of the module, we will look at event sourcing, which is a way of storing events in our databases. So the traditional approach to storing data, normal data in a database, is to store the current state of a record, i.e. an entity, as a record in the database. So this one record represents the most current state of an entity in terms of all the fields and properties. And the event sourcing pattern suggests an alternative approach to storing the state of data within a database. So instead of storing the state as one record, instead we store the state as a series of events which all sum up to the current state. And therefore each event record you store basically just states what has changed for that entity. It doesn't state the entire current state for that record, for that entity. And in order to get the entire current state of an entity, you have to replay all the event records in the correct order. So on our order service diagram here, we have a series of events which are stored for an order. The first event basically says the order was created, and will have the state for when the record was created, for when the order was created. But every subsequent event record that's been recorded basically details exactly what has changed. So for example, the second event that happened in relation to this specific order was that the location of the order has been changed. And then the third event is to do with the quantity within the order changing. So in order to work out the complete current state for this order, we would have to replay events 1, 2, and 3 in the correct order in order to work out that this is the order, the location is B, and quantity is 23. So the next question is, why would we use event sourcing? We've already seen the argument for using events to share data with other services, but why would we use event sourcing to store the data as events within the local database? One of the arguments is it's more efficient to store and broadcast as an event exactly what has changed on an entity instead of broadcasting the entire entity. An additional argument is that by storing the events in such a way, we have the ability to work out the state of a specific entity at a specific time. So for example, for an order, if I need to work out the total cost of packaging, delivery, and dispatch, I can do that with event sourcing. Even if the order was for a date, let's say last year, I can easily replay the events to a certain point, and then work out exactly how much the packaging was at the time, how much the dispatch was at the time, and how much the delivery costs were at the time. I could replay events to a certain point in time to work out the exact state it was in at that point in time. And if we take this idea back to the idea of sharing data as events, all the services that are interested in a particular service's data, if they store the events that that service broadcasts locally in their local database, they have the same ability to work out specific values at a specific point in time. So in summary, event sourcing sounds great for storing events, especially if we're using event-driven communication to share data. There are, however, a few challenges that you will face if you decide to use event sourcing in order to store events within your database. One of the issues is as the events build up, you'll have to replay more events, i.e. consolidate more events in order to work out the current state for a specific entity. And as the records build up, the performance will decrease because you are having to crunch more records. And one way to resolve this is any events that are too old to be of any interest, you might decide to consolidate into a flat record, basically take a snapshot of that entity to that point in time so that we have a flat state record, and then we start piling events on top from that point. And we can use the same snapshot technique to consolidate the events into one record to address any concerns around storage. So if we build up the database to a certain level and we have too many events, we can reduce the database size by consolidating the events using the snapshot technique. So let's have a quick look at a visual diagram to see how event sourcing works alongside event-driven communication, where we're trying to share data in the form of event updates. So on the left-hand side, you can see our order service is storing all changes related to an order as a series of events to the database. And at the same time, each change is being broadcasted as an event to a message broker. And this event might only include the change related to an order that has taken place, not the entire state of the order. And then any parts of the system that are interested in an order's state changing can then subscribe to the queue from the message broker and pick up the change. And then they can carry out an action on behalf of that order change, or they can store the order change in their own local data store if they need it for other types of querying which is associated with that service's data. In the next section of the module, we will look at another pattern called CQRS, which further changes the design of our database to make it more microservices friendly.